So, welcome back to All This Math. This is Professor Parker. Please make sure you're subscribed to the All This Math YouTube channel. Please drop a comment down below, or if you have any questions about what I explained, please put your questions in the comments so I can know what your questions are. All right. Also, like the video. Please hit the like button, hit that thumbs up. All right. And share this video with somebody else. All right. And also, free Mr. Clark. East Side High from the movie Lean on Me. If you're a young person watching this video, you might not be up on the movie Lean on Me. It's worth checking out. All right. Let's get into it. So what are we doing today? We're doing some geometry. We're using the secant-secant theorem. All right. Now, first, what's a secant? What is a secant? So in terms of circle geometry, a secant is a line or a line segment that touches a circle in two places. So you see how from this endpoint, this line segment extends, it hits the circle there, boom, at X, it hits it again, boom, at Y, right? Hits it at two places. That's a secant. And also MLK is a secant. See how I did that? We'll talk about that in a second, right? It extends from point M, it hits the circle right there at L, boom, and it hits it again at K, boom. All right. Now, MX are the initials of Malcolm X or Omowale Malcolm X or El Haj Malik Al Shabazz. Yeah, this is the year 2025. This is the 100th anniversary of his birth. He was born in 1925. All right. And also, this segment over here is named for MLK, the good Reverend Dr. Martin Luther King Jr. You know? All right. Two people that we should actually study, right? Those are two people that are very famous, right? But so famous that so many of us know literally nothing about them. And we think that because Dr. King has a holiday or there's a holiday for Dr. King every January, we think, oh, well, we don't need to really read the books that he wrote. He wrote 3 books, right? Left us a lot of speeches, right? A lot of essays, right? If you read Why We Can't Wait, which is his second book that he authored, he has The Letter from a Birmingham Jail, which is a long essay that's included within that. I highly recommend everybody read Letter from a Birmingham Jail. All right. Also, just so many speeches. He got a lot of speeches too, just like Malcolm X. Malcolm X has his autobiography, as told to Alex Haley, the autobiography of Malcolm X, but also left many speeches. I recommend Ballad of the Bullet. He delivered that in Detroit, Michigan in 1964. Highly recommend that. Also recommend Message to the Grassroots, another speech. All right. And The Last Message. The last message is another speech that he happened to deliver in Detroit, Michigan, a week before his assassination. All right. So those 3 speeches. And then what I suggest is going down the rabbit hole. All right. Also, there are many books, many biographical books that have been written about Malcolm X that I highly recommend. All right. Now let's get into the geometry. Now, the secant-secant theorem says this. All right. Well, before we get into what the secant-secant theorem says, because we're going to use that information in order to answer this question or to follow these instructions to find the length of LK. The length of LK, this chord right here, from point L to point K, that's a chord, right? A chord is a segment that touches a circle in 2 different places. A secant is a segment that extends through a circle and touches it in 2 places. All right. It starts on the outside and it extends through and touches it in 2 places. All right. Now, XY is 20 units. So from this point to that point is 20 units. MX is 11. From this point to that point is 11 units. ML is 13. From this point to that point is 13 units. All right. So now, what does the secant-secant theorem say? It's similar to the secant-tangent theorem or the tangent-secant theorem, but it's not quite. But secant-secant theorem says this. If you got a secant, right? The full length of the secant times the outside part of the secant is equal to, if you got 2 secants on a circle and they both extend from the same endpoint outside the circle, in this case, point M, the full length of the secant times the outside part is equal to the full length of the other secant times its outside part. So I'm going to say it again. The full length of the secant, right? So from point M to point K times ML from point M to point L is equal to MY times MX. That's secant-secant theorem. So let's write that up. Let's write that up real quick. So that's going to say, so we're going to say MY times MX is equal to MK times ML. All right, so that's the whole secant times the outside part of the secant is equal to the whole secant, the other one, times the outside part of the other one. All right, now we got it set up, we got our equation set up. Now let's replace our segments with their numerical values. So what's my? My is from this point to that point. So my is equal to mx plus xy. Mx plus xy. And then mx, I'm going to just write this again. I didn't mean to do this, but I forgot about this step because I forgot I had to basically like break my up into two segments. See, my is two segments. It's this one plus this one. And the same thing with mk. Mk is this one plus this one. So I wasn't planning on doing that, but it's all good. ml plus lk times ml. All right, now what's mx? Mx is 11. Let's replace that with 11. xy is 20. Replace that with 20. What's mx? 11. Boom. See what I did there? Make sure you know where the MX, where the 11 came from, where the 20 came from, where the other 11 came from. Whenever you watching somebody in a class, and this is a class, you're in my class right now. Welcome to class. Hope you're paying attention, right? Whenever you watching somebody in class, a teacher or one of your classmates goes to the board and they just write numbers on the board, make sure you understand where the numbers came from. Make sure you know where this 11 came from, where it came from. We replace MX with 11. Why? Because it says MX equals 11. That's why. Where this 20 came from? XY. Why? Because this says xy equals 20. Where did this mx plus xy come from? This said my. Oh, isn't my from this point to that point? And isn't that made up of mx plus xy? That's where this came from. Always make sure you know where everything came from. And if you don't, be bold enough. Don't be scared. Raise your hand and say, yo, where did that come from? Maybe you don't say yo, depending on who your teacher is. They might not like that type of language. I don't know. But anyway, like you in my class right now, you watching this video. If you don't understand something, put it in the comments. Go ahead. Excuse me. All right, now ML. ML is 13. So we about to replace this ML with 13. Bring the plus side down. What's LK? LK. Oh, that's what we're looking for. Find the length of LK. We about to figure that out. You put a question mark right there. We don't know what LK is. Boom. What's ML? ML is still 13. Well, not still. I ain't used that yet. All right. Now, let's break this down. 11 plus 20, 31. We got to know our addition facts. We got to know arithmetic. 11 plus 20 is 31. Then we're going to 31 times 11 in the next step. Then we're going to do, all right, 13 plus LK. 13 times, let's distribute this 13 to both of these. 13 times 13, 169. You should know your multiplication facts, right? Your 13 facts. And you should know your perfect squares. 169 is a perfect square because 13 is its square root, right? If a number has a square root if a number has a square root that's not a whole number, it's not a perfect square. But everything got a square root though. Every number has a square root, to my knowledge. But if a number has a square root that is not a whole number or integer, then it's not a perfect square. It's something, but it ain't a perfect square. Like 8. 8 got a square root, but it ain't a whole number. It's like 2 point something. 9 is a perfect square because 3 times 3 is 9, and 3 is a whole number. 4 is a perfect square because 2 times 2 is 4, and 2 is a whole number. But if your square root ain't a whole number, then you're not a perfect square. Keep that in mind. All right, so then we got 13 LK. Why am I using LK? Now we about to do this, bro. So LK, we're gonna call that X. Yeah, we're gonna let X equal LK. Because I don't want to just use like two letters. You know what I'm saying? That might confuse things. So let's say LK is equivalent to X because it's our unknown value, right? LK is our unknown value, so we're gonna call that X. All right, so now we got 31 times 11 over here, 169 plus 13x. Make sure you know where everything came from. 13 times 13 gave us 169. We replaced the LK with an X, so 13 times X is where we got 13x from. Now, 31 times 11. What I would do, I would break this 11 down into 10 plus 1. That's what I would do. That's me personally. You might not want to do it like that. You might break the 31 down into 30 plus 1. I don't know. It don't matter. You're going to get the same product anyway. But 31 times 10, That's 310, right? But that's only 10 31s. We need one more 31. We need one more 31. So 310 plus an extra 31 is going to be 341. 341 is equal to 169 plus 13x. All right, now I'm trying to isolate x. So I need to get rid of two things. The 169 and the 13. The 169 and the 13. They got to go so x could be isolated. So let's get rid of the 169. What operation do you use? We do the opposite of whatever 169 is doing. 169 is just a positive 169, just chilling. If you're just positive and you're just chilling, then the operation is actually positivity or addition. Addition, right? So what's the opposite of addition? Subtraction. So we're going to subtract 169 on the right side. Oh, we keep it balanced. If I subtract 169 on the right side, I got to subtract 169 on the left side too. So then I'm going to do minus 169 over there. Boom, boom, cross him out. That's 0. If it's 0, you don't got to write it though. You don't got to write it. 341 minus 169, I think that's 172. The way I do that mentally, I round this up to 170. And I round this down to 340. 170 and 340. Oh, you know what? 170 times 2 is 340. 170 plus 170 is 340. You know how I know that? Because 17 times 2 is 34. So 170 times 2 is 340. Yeah, see how that works? And then we add the 1 and we add the 1, right? Because we rounded up from 169 to get 170. So we got to add a 1. We rounded down from 341 to get 340. So we got to add that 1. So that gives us 172 is equal to 13x. 172 equals 13x, right? Now, how do you get x by itself? Get rid of that 13. How though? How you going to get rid of the 13? You do the opposite operation. This is multiplication. 13x means 13 times x. That's multiplication. So you do the opposite of multiplying, which is dividing. Divide by 13. Do it on both sides. We got to stay balanced. 13 divided by 13 is 1, which gives us 1x. 1x, don't nobody say that. We just say x, because that's how many x's we got. 1x and x are equivalent. All right, so this gives us equals x. What's 172 divided by 13? Something crazy. 13 is not a factor of 172, which means when we divide, we're going to get a decimal. When that happens, we can just leave it like that. And we can't reduce this fraction because 13 is a prime number anyway. So 172 and 13 don't have a common factor besides 1. So this is our final answer, right? This is, and remember, we just temporarily let x lk equal x. So this is really lk. So lk is 172 over 13, right? But it's like, I mean, it's like 13 and some change because 13 times 13 is 169. 13 goes into 172 13 times with 3 left over. So it's like 13 and 3 13s. You know what I'm saying? 13 and 3 13s. That's like 13 point. I mean, 3 times 4 is 12. So 3/12 will be 0.25. So 3/13 will probably be like 0.2. So I'm assuming, right? I ain't even gonna grab the calculator. I'm assuming this is like 13.2. I'm assuming because 3/12, like follow me, right? Follow my logic. If this was 3/12 instead of 3/13, it would be straight 0.25. Because 0.25, 3/12 is a quarter. It's 1/4. 1/4 is equivalent to 0.25. But that the denominator is one more than 12. So it's going to be something close to 0.25. But dig this. There's something you should know about number. You should have this number sense. You should know something about fractions. When the numerator stays the same, but the denominator gets bigger, the value of the fraction gets smaller. As the denominator gets bigger, the value of the fraction gets smaller. Because just like you cutting it up into more pieces, so each piece is going to be smaller and smaller. Like if you got a pizza with 8 slices, you know what how big the slices is. If you cut each of them slices in half, now you got 16 slices, but you know the slices are smaller. So a 16th is smaller than an eighth. A 16th is smaller than an eighth. As the denominator gets bigger, the value of the fraction gets smaller. Don't ever forget that. That's game. I'm putting you on the game. All right. So this is probably like 13.2. I know it's less than 0.25, but it's close. You know what I'm saying? It might be 0.22, 0.21, something like that. You know, but we can round it off to 13.2. But anyway, that's how you use the secant-secant theorem. Remember, you got two secants coming extended from the same point outside the circle. You take the whole length of the secant and multiply it by the outside part. That's equal to the whole length of the other secant multiplied by its outside part. All right. And that's how you set up your equation, because that's what we do in geometry. In geometry, we take the theories and the postulates and all that, and we use it to set up an equation. Once we set up an equation, then we can solve for or figure out the missing piece that we're looking for, whether it's an angle, whether it's a side, whether it's the length of a line segment, like up here, a chord, whatever, But and then we do algebra. That's why you got to know algebra. You got to be tight with the algebra. If you don't know how to really solve equations, I got a whole playlist on solving linear equations that you need to go binge on, right? On this channel. All right. So make sure you subscribe to the channel. Make sure you like this video. Share this video with some other people. And also, if you got any questions about anything I did up here, put your questions in the chat. Not the chat. It's not a live. It's not a Zoom or nothing. Put your questions in the comment section. That's what I'm gonna say. Put your questions in the comment section. All right. All right. See y'all later. Free Mr. Clark.